What's up again, BMS? This is part two of human impact. Here we go.
So let's talk about pollution. I know I'm going through this fast. Listen fast. Pollution, is contamination of the land, of the water, or of air caused by waste, chemicals, noise, heat, light, and other sources. Tons of other sources. Could even be volcanoes. Okay, Mr. Cook talked a little bit about volcanic activity. Directly related to population growth and resource use. So when populations grow, guess what's going to happen in those areas? You're going to have pollution, an increased amount of it. Okay, and when we use more of different resources, guess what? There's going to be pollution. So what we're trying to do, and it's everybody's job, is to try and find ways when we do use resources, because we have to have them, that we do it in the right way. Okay, so that's kind of what we're talking about, being aware of it. All right, so your types of pollution. I'm not going to read all of this, but land, you've pretty much either got solid or hazardous waste. Okay. Solid waste, your packaging materials and scraps and things, construction debris. Hazardous waste, that's the dangerous things like pesticides, for example. Okay. There's like a big restriction on certain pesticides on crops for farmers, because what's happening is not only is dangerous to the vegetation, but that would run off into water sources, and then your water is now what? Contaminated. Okay. So it's hazardous. Even radioactive material. Okay. When they came out with like nuclear energy, we've got two or three different plants in the state of Arkansas Nuclear One up in Russellville. Okay. That's an enormous, great energy source that we have. But what the problem is after they mine that, and they split the atoms, and they use nuclear fission, okay, to pull that energy pretty much and transfer it into power, what happens is all of that leftover material is radioactive. So they have to find some place to do that, okay? Maybe a big plot of land, and they bury it. It's just crazy. So that's would be like hazardous waste pollution. Water pollution, fertilizers and pesticides. That's what I was talking about. It kind of went with the hazardous waste. Sewage, chemical sediment, heat from power plants. Okay, those things can get into the water. You ever heard of acid rain? Okay, that's what that's from. Okay, pollution in the air. So there's outdoor and indoor pollution. Of course, air. We've got like our fossil fuel burning from plants and stuff like that. Okay, which is what Mr. Cook talking about, the Industrial Revolution. You're talking about all of those fossil fuels being burned, and mining for oil and all that stuff, or coal. That would put pollutants into the air that was toxic. Okay, exhaust from vehicles. Talking too fast. That's probably one of the biggest things along with the Industrial Revolution. One of the things that they started was building cars. Okay. And those cars, each individual car lets off a certain amount of exhaust. Guess what? That's toxic to the air. Indoor, dust, pet hair, glues, cleaning supplies, smoke, carbon monoxide, radon, things that can be found indoors. So these are types of pollution here. Okay, so pollution issues. There's a lot. Okay. Rainwater can mix, create leachate. Capped landfills can only be used for recreation sites, not housing. Agri, hazardous land causes serious health issues like cancer and diseases. Deciding landfill location, that's a big one. Okay, because if you've ever been to the landfill with your parents or guardian or whoever it is, okay, it's a big pile of trash. What to do with it, honestly. Water, okay, the issues with water, runoff into the water, it's going to make it unsafe to drink and unsafe to use. Okay, oil spills. We saw the big Shell oil spill a long time ago. Okay, things like that can happen. Air, look at these. Smog from it, okay, from exhaust, acid rain, talking about that a while ago. The CFCs from air conditioners. There was regulations put on CFCs a long time ago They thought that was the reason for the ozone hole. Okay, well, when they cut and they made regulations on the ozone, or regulations on the CFCs, the ozone actually began to repair itself. That's what they believe it might have happened. So greenhouse gases are increased because of CFCs, people not using them correctly due to regulation. All right, so where does that come in? So in conclusion here, let's talk about this. Questions to ask. How could we monitor or minimize human impact on the environment? Okay, monitor and lower or minimize human impact on the environment. Okay, so how would we do that? So the first thing really as a scientist, you think of, well, how have we done it successfully? Okay, to go back and iterate and change ways. You try something, well, maybe it didn't work too well. Well, these are some of the things that we have done that I can just think off the top of my head. Go get your utility bill. Seriously. Okay, you might have natural gas. There's even ways that these companies have put in to show you how to lower, okay, your usage. Go look at your water, how much, gallons that you're using monthly, and see maybe a way to do that. Okay, people are collecting rain to water their plants rather than using fresh water or good clean water. Okay, that the city's cleaned. Restrictions on building. Okay, so we use, well, let me go back to A. So your utility bill, that's a way that we are being monitored by use, even your electricity bills, okay, all of your utilities. So restrictions on buildings, okay. If you build in the city limits, you have to follow a certain code, okay. So they're trying to make sure and all of those limitations, of course, they want a good, sturdy, safe building. But at the same time, those restrictions allow them to make sure people aren't just choosing plots of land and building anything and everything they possibly want to. You've got to go through steps and things to buy land. And so there are restrictions set in place. Think about C, renewable resources. Okay. Those are actually ways that we have been able to minimize human impact, okay, using renewable resources, things that are renewed at a like a very accessible rate. Like hydropower is water. We know it cycles, but we also know like what kind of water are you going to use, okay? Because if it's somebody's fresh water and there's already a shortage, you're not going to be able to. Geothermal, Hot Springs is known for this. Okay, they have a geothermal plant. They use the hot water to turn the turbines and to generate electricity, renewable resource, to replenish fastly or very quickly. Solar power, it's the sun. It's not going to run out. Biomass, okay, burning waste or using that biomass or waste in an effective way. Wind energy, okay. I mean, go across the state of Kansas into Colorado, and you see tons of wind turbines right across the area, and they're all facing pretty much California. They're facing the west. Why? Because the westerlies come through. So they're using what the resources that they have. And there's even been restrictions on fossil fuel use and the lowering of that and the decrease, and putting like things like scrubbers into the exhaust that's going to go into the air to try and clean it, and then they'll use that stuff, okay, that they cleaned to make cement or to make roofing shingles and things like that. So they're trying to minimize ways, okay, that we're using. So thing is, you just want to be cautious. Two last things. Per capita. What does per capita mean? That means individual usage. Okay, so if you look here, this is like individual use. So you want to see like this is food, okay, per calorie. And what's crazy is I just want to say this one thing. Okay, the average American's daily calorie consumption increased from 2,054 calories in 1970 to 2,500, over 2,500 in 2010. I mean, you're talking about a 40-year period went up almost 500 calories a day. Okay, that's a lot. Daily calorie consumption. Think about in another 40 years. Well, we've already gone through 10 of those. Okay, it might be up over 3,000. That's pretty crazy. Okay, so even food use. All right, so per capita means individual use. So when you see that, so this would be like a graph that shows the different areas of food or the different foods that we use. Then the last one, water. Kind of, we've already talked about water, but this is a circle graph showing parts of a whole. Okay, and the daily per capita use. Okay, for us here in Americans. Okay, withdrawals in U.S. for all uses were estimated to be 322 billion gallons per day, 9% less in 2010. Okay, so there's the biggest usage. Look what the biggest usage is. Oh man, look at that. Toilets. Toilets. Flushing your toilets. We won't talk anymore about that. But, anyways, households with more efficient fixtures and no leaks can drop their water usage to 40 gallons per person per day. Look at that. The household, 240 gallons of water daily for indoor and outdoor use. That's just a lot, you know? So, anyways, there's some graphs, some facts, some evidence